Good morning, students. Welcome to the third part of the hands-on session using MATLAB. And today we'll look for a couple of another mathematical methods and how we can code that. So let me just share my screen with you. Just give me a minute, please. Okay. So is my screen visible to all of you? Yes? No?
Yes, sir.
Okay, great. So uh, we'll move to the fourth practical, which includes the two mathematical iterative methods, that is Jacobi iterative method and the Gauss-Seidel iterative method. Both of these particular methods are used for solving linear equations. So now let us see that if you can see on your screen, you have three equations, and now what is the basic difference between Jacobi method and Gauss-Seidel method is what we'll see. So first, let us write down the equations. So today, instead of Paint, we'll be using OneNote, which makes it a little more convenient to use. Somehow it was not being loaded yesterday. So unfortunately, we have to use Paint, but now we have a better option. Anyways, so my first equation is 20x1 plus x2 minus 2x3 is equal to 17. My second equation is 3x1 plus 20x2 minus x3 is equal to minus 18. And the third equation suggests 2x1 minus 3x2 plus 20x3 is equal to 25. So this is the equation that we'll be dealing with. Now, the very common phenomena here is whenever we are using this particular equations, we always see that for x1 in the first equation, the particular coefficient of x1, or let's say the absolute value of coefficient of x1 would always be greater than the combination of, or say the addition of coefficient of x2 and x3 combined. Similarly, if we talk about the second equation, the coefficient of x2 would be usually greater than the coefficient of x1 and x3. Again, I'm talking about the absolute values. I'm not talking about, say, if this is 3 and this is minus 1, we'll take the absolute value. So that would be 3 and 1. So from 4, 20 is far greater than 4. So again, this is a comparatively, in such cases, it becomes very easier to reach to the solution. Again, talking about the third equation, you have 20 as the coefficient of x3, again, which is greater than 2 plus 3, that is 5. So as I said, we are taking about the uh, absolute values of the coefficient. So we'll not take this as minus 3, but we'll take this as 3. Now, if we talk about the Jacobi method, what we do here is we make in the first equation we make x1 as the subject of the equation. In the second equation we make x2 as the subject of the equation, and the third equation we make x3 as the subject of the equation. So if we do this, we can write this equation as x1 is equal to 17 minus x2 plus 2x3, and this is whole divided by 1 by 20. I hope you all agree to this. Any doubts here so far? Yes, no? Okay, fine. Moving to the next equation, you can write here my x2 is equal to, we have minus 18 on the RHS, so minus 18 minus 3x1 plus x3. This whole term is divided by 1 by 20. Okay. And lastly, making x3 as the subject of the equation. So my x3 is equal to 25 minus 2x1 plus 3x2. This whole part is divided by 20. Let me just say this so that okay. Anyways, so once we have got this, now you cannot further solve these equations because you don't know the value of x2 and x3 in the first equation. The value of just a minute, just change the color so it becomes easier for you. You don't know the value of x2 and x3 in the first equation. Similarly, you don't know the value of x1 and x3 in the second equation. Similarly, you don't know the value of x1 and x2 in the third equation. If you know these values, you can calculate your x1 and x2 and x3. So for the first approximation, what you take is my x1 value is equal to 0. Similarly, x2 value is equal to 0. And similarly, x3 value is equal to 0. So this is what you assume in the first case. So when you do this, when you are calculating my x1, in that case, I'll place the value of x2 and x3 as 0. Similarly, when you are calculating my x2, I'll place the value of x1 and x3 as 0. Again, if you are calculating my x3, I'll place my x1 and x2 as 0. Now, this is when you are calculating for the first time, you have to calculate this for a number of iteratives. So what you do is for the first iteration, or say for the first cycle of calculation, this is what you do. So let us implement 0 here for x2 and x3 in the first equation. So if you do that, what you get here is my x1 would be equal to 1 by 20. Now x2 is 0, x3 is 0. So this would be simply 1 by 20 into 17. Similarly, if I talk about my x2 value, I am placing my x1 and x3 as 0. So what I'm left with is 1 by 20 into minus 18. And similarly, x3 value is again 1 by 20 multiplied by, this is 1 by 20 multiplied by x1 is 0, x2 is 0, so that is 25. Okay. So calculate these values and tell me what is the answer. 17 by 20, what would be the answer? Yes. Simple mathematics, please focus and be attentive. What would be the value? So we have in total of 12 people attending, including myself. So I presume that there is at least someone in the audience from 11 people who can answer what is 17 by 20.
0.85.
Thank you so much. 0.85 is my x1. Similarly, if you calculate 1 by 20 into minus 18, so that turns out to be
Minus
minus
0.9.
0.9. Great. And similarly, 25 by 20, that is 1.25. Now,
1.25.
great. Now, this is the answer that you have received for the first iteration. Okay. Now, what we do is we calculate the same thing using your new x1, x2, and x3. See, initially you had used your values, your x1 was 0, x2 was 0, x3 was 0. Now you have new x1, new x2, and new x3. So now what is your new x1? That is 0.85. My x2 is minus 0.9 and my x3 is 1.25. Correct? So using this value, you will again place when you are calculating your x1, you will place this new values of x2 and x3 in these particular places. Then again, while calculating x2, you will place the value of x1 and x3 in these places. The equation does not change. The values of x1, x2, and x3 changes. Similarly, you while calculating x3, you will place the new values of my x1 and x2 in this particular equation. So once you do that, you will get again new values of x1, x2, and x3. So here, if you do this, you would say that, sir, this is an unending process. You can do this for n number of iterations. You can do it for 100 iterations, 200 iterations, 300 iterations. So why are we doing this? Or how do we end this process? When can we take this as that, okay, this is something that we are, we'll do this for only 100 iterations, 200 iterations, 300 iterations. How do we decide that when we have reached our answer? So for that, there is a term which is called as accuracy of the answer that you require. Let's say, or say, you can also use the term as error tolerance. Let's say I want my error as 0.00. So if I have the first two terms as same, let's say, for example, if I say my first value is 3.0095, and in the next iteration, if I'm doing it and getting the answer 3.105, so in that case there is a accuracy which is less than this particular tolerance. So what I'm doing is less than this particular error limit as well. So I'll further calculate this till this particular value comes down to 0, or these two values, the first two values after the decimal matches each other. Of course, this the first digit has to match, but also the two digits after the decimal matches. So you can calculate till that particular value. Again, based on the application, whatever accuracy you want would be decided. So based on the accuracy you are selecting, your loop would run for that much amount of times. Now, keeping this, any doubts in the mathematical solutions that we understood? Anyone who wants me to repeat, or anyone who has any issues in understanding that how we are solving this particular Jacobi method? If no, then we'll move to the MATLAB code. Okay, fine. No hands raised, so I presume that there are no errors, I mean, in understanding, or say no confusion as of now. So let us start with the Jacobi iterative method. Just a minute. Okay, so let us start with okay. Now let's go through the code. First, it says clear the screen, that is CLC, then it is clear all, so it clears all the values from the workspace. Then it is asking you to enter the, input the unknown variables. Now, again, as we have seen in our questions, we have total 3 unknowns, that is x1, x2, and x3. So here we will input the number of unknown variables as 3. Once that is done, we are asked to enter the relative error limit in epsilon. So whether you want the error, whether it is in positive or negative, what is the amount of error that is tolerable? So as we had seen in this our example, say this is 3.0095, this is 3.0005. So this would be previous case minus the current, so this value would be negative. If you are, say, having this value, let's say 85 and this is 95, in that case the error value would be positive. So but what we are looking at, that we want this thing as constant, the first digit before the decimal and the 2 digits after the decimal, if your answer is in single digits. If you have, let's say, answer something like let's say your answer is, say, 29 point let's say 3705, for example, and then you want, if you are getting your answer as, say, let's say 39.3715, so that is still not acceptable, because this particular value is not matching. I want this to turn out as 29.37 something. Then this is something which I can consider. So I am looking at a value where I am able to take this errors for at least 2 decimal places. But here, let us, for ease of understanding, let us take this as absolute relative error. I want at 0. Now, if I take this as 0, now I don't know that how many iterations would be required to complete this entire solution. And since to reduce my work, I am using this code. But code also does not know that when would be, when is it that you will be getting your answer. So for that particular reason, let us take any particular random number. So I can take 200, 500, 700. So let's say I'm using 500, that I want to calculate this for 500 iterations. If I get my answer below that, automatically the loop would exit that. But just in case if I'm not getting the answer before that particular value, in that case, my loop would run for 500 times, and then it will give me the final values. But it would still not say that this is the final value which is expected by you under the error limits mentioned by you. Fine. So, okay. Now, just for the estimation point of view, we have mentioned that the maximum time we want to run this is 500 times the entire loop. Now, here what we have considered is biggest error that we want is 0. So the answer of this iteration and the answer of next iteration, there should be no error in that. So the biggest error that we have considered is 0. Now, coming to this part of the code, I want you to tell me that what is it trying to ask. We have done this yesterday also a couple of times. So I want you to understand this and tell me that what is it asking me to do. What does I and J represent? Most of the students are from computer or IT backgrounds. I'm sure this would not be that complicated for you to understand, and you would be definitely be able to answer this, but you need to respond. That is what is my ask. Yes, student, hurry up, please answer this.
Row and column.
Yes, it represents the row and column. And what does the code ask for? Code आपसे क्या मांग रहा है? What
Elements
is
of
the?
matrices. Elements
Yes,
of
it is
matrices.
asking you. Yes, good. It is asking you for the elements of the matrices. So now here again we'll come to the equations. So here it is asking me, if I reach here, enter the A11 element of the matrix. So what would be, now see, these are the three equations. What would be A11? What would be A11?
20.
A11, yes, A11 would be 20. Similarly, what would be A12? That would be 1, because coefficient of x2 in the first equation is 1. Similarly, the next it is asking me is to enter the element for A13. So again, what would be A13? A13 is the coefficient of x3. So here it would not be 2, but it would be minus 2. And finally, since we are looking for an augmented matrix, so it is asking me to enter the element A14, that would be 17. Similarly, the next part it is asking me is, now see here we have completed the j from 1 to n plus 1. So from j 1 to n plus 1, that is n is 3, that is unknown variables is 3. So 1 to 4 we have already entered. Now this loop is again ended. We are again jumping into the I loop, and now there is an increment in the I loop from 1 to 2. So now we are moving to the second row. In the second row, again we'll run this j loop. So here the value of coefficient of x1 in the second equation is 3. So the value of A21 would be 3. Similarly, next the value of A22 would be 20. Again, talking about the third value, that is A23. So that would be minus 1. And running the J loop for the last time for I is equal to 2, it is asking me the value of A24, and here the value would be minus 18. Once this is done, again it would exit the J loop, and again it goes back to the I loop and increments I from 2 to 3. Now since n value is 3, so this is the last time I loop would be running. And again for I is equal to 3, we come back to the J loop which runs from 1 to 4. So it will ask me again 4 times for the input. So for the third equation, or say the third row, my A31 would be 2, my A32 would be minus 3, then I have A33, that is 20, and finally the last A34, that would be 25. Okay, now let us come back to this part. Fine, so we have entered this particular matrix. Now what it asked me is enter the initial Gauss X. Now, if you again recollect this particular part, so here what we had seen was okay. So initially what we had taken was x1, x2 and x3, we had taken the initial values as 0. So similarly here what we'll do is we'll take the initial values as 0. So x of 1 would be 0, x of 2 would be 0 and x of 3 would be 0. So once we have done this, we have done this part of the loop, which says I need to run this and enter this from 1 to n. So I have 3 unknowns. So n is 3. So I need to enter the initial values of x, 1, 2, and 3. Okay. Now, once this is done, I come back to this particular part where I'm running the loop for k, where k is equal to 1 to the maximum iterations. The maximum iterations, we have already mentioned that we are calculating this for 500 iterations. Okay. Next is the biggest error that we are taking is 0. Now for I is equal to 1 to n, sum of LHS is equal to 0. Now we have taken a term, we have created a variable which is called as sum of LHS. So right now we are taking that, since we don't want the sum LHS to take any sort of garbage value, so we are taking the sum LHS as 0. Now let us get into another loop under I, and that is run by a variable called j. So for j is equal to 1 to n, if I is not equal to j, so this would run if this condition, you will get the sum LHS is equal to sum LHS plus Aij into old of xj. You will get this thing only if I is not equal to j. But since you are running this loop for the first time, so your I value is 1, your j value is also 1. So this does not exist. So if this if condition is not satisfied, you don't get this. Okay. Your sum 0 was already printed when I is equal to 1. So you already see this sum 0 first here. But if this does not exist, you end this particular loop. Okay. See, this end is for this if, this end is for this for. So you end this. Again, you come and run this particular loop for I is equal to 2. So for that, once you do that, again, it says your sum LHS is 0, and now you have your value of I as 2. So I value is 2, but now j again starts from 1. So now both of them are different. So sum LHS is equal to sum LHS, which was the initial value, which is 0, plus Aij. What would be Aij? That is A21. A21 multiplied by the old x2. Again, x2 is 0. So 0 multiplied by anything would be 0. So that would again give you this particular product as 0. And the initial value was also 0. So again, you see your sum as 0. Now coming to your new xi. So your new xi is equal to a of I1 and n plus 1, that is 4, minus sum divided by, now see how we are getting this value is, see, pay attention here. Yes, any doubts? Okay, fine. So new xi, your a is equal to I into n plus 1. Okay, so when my I is 1, so new xi would be I is 1, 1 and n plus 1, that is I4, sorry, A14, that would be AI n plus 1, okay, minus some LHS which is 0 divided by AII, that is 20. So that would be 17 by 20. So this is exactly what we had done here. We had done here 17 by 20 and we were getting a value of 0.85. So here again the code does the same thing and you get your new xi for the first case, that is 0.85. I hope you are with me on this. Fine. Now it also asked for a relative error. So what is relative error? Relative error is absolute value of new value minus old value. Okay, irrespective of whether it is positive or negative, I'm not concerned. New value is 0.85, but my old value was 0. So the relative value, which is the absolute of this particular difference, also turns out to be 0.85. Now it says if the relative error is greater than the biggest error. What was our biggest error? We had already mentioned that I want my biggest error to be 0. And what is my relative error? My relative error here, which we have calculated, is 0.85. So here my relative error is greater than the biggest error. In that case, I'll make my biggest error, which is equal to the relative error. And that would end this. Is this clear? Are you understanding this? Any doubt so far? Yes, I can hear someone talking. Is any doubt so far here? Okay, fine. Fine. Now let us move to the next step. Now we have calculated this. Now again we'll go for again we have seen for I2. Now again if we go for I2, my new x of 2, that would be a of 2 comma 4. So what would be 2 comma 4? A of 2 comma 4. Let's move back to the matrix. Just give me a second. Yeah. Okay, a2 comma 4, that is minus 18, okay, minus some 0, which was again for x2, again the sum is 0. So 18 minus 0 divided by AII, so that is A22. Okay, so A22 is 20. So again minus 18 by 20. So that gives me my relative error of 0.09. So this is again what we had calculated here. You can see minus 0.9 here. So again you get a relative error of minus 0.9. Once you have calculated this, again let us calculate. We know the biggest error is 0. Now again your relative error is new error minus old error. Your new error is minus 0.9 minus old error is 0. So the answer is minus 0.9. But since we are looking at the absolute value, my relative error is just 0.9. Okay. Now again, looking at this if statement, it says that if relative error is greater than the biggest error. My biggest error was again 0, but the relative error is still 0.9. So that is greater than the biggest error. So in that case, I'll put this value in the biggest error and make my relative error as the biggest error. So initially the biggest error, which was 0, is now turning out to be 0.9. Okay, once that is done, we again rerun this loop and we find out the third part in the similar fashion. That is, I get it as 1.25. Now how did I get this 1.25? Simply 25 by 20. So what is here 25 by 20? Here I get it by again, this is A3, 4 minus some 0 divided by A33, that is 20. So 25 by 20, which gives me another relative error, which is 1.25. Now again, the biggest error is 1.25 now. Fine. Now, in the next case, what I do is, now this is the first time that we have run the loop. We have completed this part. We have reached this particular place. Now what we are doing is we are taking these values, which are your new x, and now we are placing it in this place, which was your old x was 0, 0, 0. Now we are placing this value as old x and going for the second iteration. Okay, so that is what happens here. Once this is done, your old x is here. Now for n is equal to 2, again we place these particular values. So initially we did not have a particular value. Now we have a value. So it takes my old x as 0.85 minus 0.9 and 1.25. Using this, it again recalculates the entire structure. So once that is done, I get this my LHS sum 0 minus 0.9, and this again, what you get, my new x is 1.02 minus 0.9 and 1. So here this x2 and x3 has not changed here. Using this particular thing, I am only getting my new x1. Okay, again taking the relative error, making it as the biggest error. Now if you can see, while calculating my first, when I had calculated this as 0.85, my relative error was 1.25. In the second case, when I'm calculating this again, my relative error is dropping down. Okay, so again it drops down to 0.17. How did it drop down to 0.17? So it's simply 0.85, that was the old value, minus 1.02, that would give me 0.17 as my relative error. Now again, this becomes my biggest error. So initially the biggest error was 0 minus 0.85. So initially the biggest error was 0.85. Now the error has reduced in the second iteration to 0.17. Similarly, we do the same for finding out x2. Now initially in the first case, what I found out, my x2 was 0.9. In the second case, I am finding this to be 0.96. In the second case, my initially it was x3 was 1.25, and now it is coming out to be 1.03. So again, the relative error is reduced to 0.22. You keep on repeating this process till the time your relative error goes down. If you can see, the relative error in the third iteration goes to 8.5 into e raised to minus 4 and so on. Since you have asked for your the error limit, you have asked this as 0, so it would keep on calculating till you get this, and also your biggest error you wanted as 0, so it will keep on generating this. It will keep on running this till the time either you reach a solution or you reach 500 iterations. So once this is done, let us see what is the answer it is providing. So it keeps on running, and you can see the relative error is dropping to e raised to minus 12. So that is 10 raised to minus 12. Again, keeps on dropping. And finally, you can see the relative error to be 10 raised to minus 13, 10 raised to minus 14. So as the e raised to minus term increases, that indicates that the amount of error is reducing as in when it is calculating. See, it is now e raised to minus 15 and so on. So yes,
you need food.
Sanjana, you want to say something? Or you can mute your mic. Thank you. Anyways, so once this is done, you can see that this keeps on, and at the end of the 10th iteration, I can get my solutions as 1, minus 1, and 1. So this is what it keeps on churning the answers till the time it reaches its maximum value. So it keeps on reducing the value, it keeps on reducing the errors, and finally you reach a point where this particular thing is solved. So again, as I said, that you'll have to practice this on and off and again so that you can understand that how this particular thing works. Is this clear? Any doubts in the code so far? Okay, let me again bring you back to this fine. So now we keep on running this till your relative error is greater than your biggest error. But what if your biggest error is now less than or equal to the error limit, which was 0 that we have mentioned initially? Once that is done, there would be the display of the result that would be look something like this. Okay, so you would see that the solution of the convergence for a particular iteration, first iteration you get this, second iteration you get this, third iteration you get this, and finally at the end of the 11th iteration you do not have any particular error. Now here again, this is also 1 minus 1 1 minus 1 minus 1 1. Here also in the 10th iteration we are seeing this 1 minus 1 1, but then again the amount of relative error is still not 0, and that is the reason it is still calculating. At the 11th iteration you can see that it is converging to 0, and here this is how you can enter this to 1 minus 1 1. Fine, and that is how the final solution uh, would come down at this particular iterative level. But this is only possible when you actually can find a solution. But what if it does not find a solution? So in that case it will print the solution does not converge in uh, the 500 iterations that we have provided. Okay, so if the solution needs a higher furthermore iterative, you need to run this with more number of iterations. So let's say you are going with 1000 iterations. If you still do not get the answer, you will get the same thing, the solution does not converge. Now when I say the solution does not converge, means we are not getting your answers in the error limit that we have mentioned. We have mentioned the error limit to be 0. So if it does not converge till it does not converge with an error of 0, it will still require further iterations. So you'll have to increase the limit of the maximum iterations that you have provided in the initial case. Is this clear? Anyone has any doubts in this particular code? The codes have already been shared with you. There is nothing secretive about it. It's just that you'll have to apply the code, run it and see how it runs. Is this clear? Any doubts so far? Okay, thank you, Anand. Anyone else? Prachi, Sanjana, Manav?
No, sir.
Okay, great. Fine. So I just want you to go through this code again for and just have a look and revise that what we have just gone through. You have also been shared with a Word file which has this particular code. So just simply go through this code, try to understand this, and we'll take up with the next, that is Gauss Seidel method, after 2 minutes of break. So it's a bio break, as well as you can use this break for revising the entire code and understanding its particular operations. Okay, students, I hope you have gone through the Jacobi method. Now, let me take you to the another method, which is the Gauss Seidel method. Hmm. So the Gauss-Seidel method is very similar to the Gauss-Jacobi method, but the only difference is here we replace the element as soon as we get the values. So here initially, like we did, again we'll make x1, x2 and x3 as the subject of the equation. So again I can write this as my x1, which is equal to 17 minus x2 plus 2x3, sorry, plus 2x3 whole multiplied by 1 by 20. Similarly, my x2 is equal to minus 18 minus 3x1 plus x3 whole divided by 1 by 20. And lastly, I have x3, which is equal to 25 minus 2x1 plus 3x2 whole by 1 by 20. So now again, this process is same for Gauss elimination as well. Jordan method as well as the Gauss-Seidel method. But the next step that we take the value of x1 as 0, x2 as 0, x3 as 0. This step is again same for the Jordan as well as Gauss-Seidel method. The next step again is the implementation part, which again turns out to be same for both the methods. So here again I'll be implementing my x1, x2 and x3 in these particular three equations. So if I do that, what I can say is my value of x1 would be equal to 1 by 20, again 17 minus x2 is 0 minus plus 2 into 0, x3 is 0, so this is again 0, so this turns out to be 17 by 20, which is again equal to 0.85, which we had seen. So now when I am calculating my x2, which is equal to 1 by 20 into minus 18 into minus 3x1. So here this x1, I'll not take this as x1 as 0. I'll simply use this particular value in my x1. So that would be 0.85 and plus x3. Now I don't have the value of x3 till now, so that is why I'll take the x3 value similar to this, which is x3 is equal to 0, and then I'll place this here. So now calculate this and tell me the just a second. Yeah, so calculate this and tell me that what would be the new value of my x2 when this is 0. So this would be 1 by 20 minus 18. And what is 3 into 0.85? Yes. Everyone? I don't think this calculation should take so long. What is 3 into 0.85? If I get an answer, we move ahead from this. Fine. So this turns out to be minus 2.55. So minus 2.55 minus 18, that is minus 20.55, and that further gets divided by 20. So my final answer comes down to be minus of 1.0275. That is my new x2. So this is my new x2. Now, when I'm calculating my x3 using this particular equation, what I'll do is for calculating x3, I'll use the new calculated x1 as well as x2. So my x3 becomes 1 by 20 into 25 minus 2 into x1, where the value of x1 is 0.85. 2 into 0.85 plus 3 into the value of x2, which is my new x2, that is minus 1.0275. So again, we calculate this entire thing, and what we get is, again, this would be 1 by 20, 25 minus 2 into 0.85. So 2 into 0.85 gives me the value of 1.7. Again, t into minus 1.0275 gives me the value of 3.0825. So again, we further calculate this. So that would be turns out to be 4.9175 divided by 20, and that turns out to be 0.245875. So this is the value of my new x3, which is my x3. So now in the next iteration that I use the value of x1, use the value of x1, which is equal to 0.85, the value of x2, which is equal to minus 1.0275 minus 1.0275, and lastly the x3 that we just calculated, which is 0.245875. So 0.245875. Fine. So this is our new values, which would be now dumped into old x of, that is x1, x2, and x3, and then further calculated. So by using this Gauss-Seidel method, what happens is you reach the solution much more faster. Although the computation increases, but the calculation required to reach your final solution with the same error limit decreases compared to that of the Jordan method. So that is the reason we opt for the Gauss-Seidel method over the Jordan method, right? So now, any doubts in the method so far? If the method is clear, we can move to the MATLAB code. Yes, anyone? Any doubts? Okay, fine. So no hands raised, so I believe that there are no doubts. So let us move to the MATLAB code. Fine. So let us run our MATLAB code. So once again, when we run this, it will ask for certain inputs from our end. So the first input it asks is, again, I need to enter the unknown variable. So again, the equation that we have for the Gauss-Seidel method, we are using the same set of equations. Right? So once we are doing that, again, I have the number of unknown variables, that is 3. The relevant relative error that I'm looking for, again, I'll take this as 0. The maximum iterations here, as I said, that initially where we are using 500, here we can, let's say, reduce down to say 200. Okay, but pretty sure that this would end before those particular number of iterations itself. Now, once you are done this with this, it says that I need the biggest error is 0. Now see, here it says the biggest error is 0, but it is not being printed here. Why is it not being printed here? Because we have a semicolon behind this line. Whenever you add a particular semicolon, the thing would be added in the program, but it would not be displayed. So whenever you add a semicolon, such part would not be displayed. Again, so once we have stated my biggest error is 0. Now you are being asked to enter the particular matrix using this particular loop. Now we have done this multiple times, so I'm not explaining this again. I will simply add the values. So let me just, okay, add the values. So my first A11 would be 20, A12 would be 1, A13 would be -2, A14 would be 17. Now the first row is complete, so we'll move to the second row. So A21 would be 3, A22 would be 20, A23 would be -1, and A24 would be -18. Similarly, moving to the third row, so A31 would be 2, A32 would be -3, A33 would be 20, and lastly A34 would be 25. So this is how we have entered the entire matrix which is required for the calculations. Now again, once this has been done, it asked me for the initial value of x. So again, for x1 we'll give this as 0, x2 again we'll give this as 0, x3 again we'll give this as 0. Now this is the same as that we had done here, that initially we are taking the value of x as 0 for calculating our first equations, which is similar to that of the Gauss-Jordan method, or just the Jordan method. It is similar to the Gauss-Seidel method here. Fine. So x1 is 0, x2 is 0, and x3 is 0. So we'll now implement this here. So once we have given the values of x1, x2 and x3 as 0, again the first x1 which is being calculated after placing the values x2 and x3 as 0, that is 0.85. So again you can see, as per our calculations also, we are getting the value of x1 as 0.85. I don't know what went wrong here, but anyways, I think it is taking a little time to load. Once I get this particular value of x1, it is again placed in this particular matrix to find the value of x2, which turns out to be minus 0.1275, which is the same value that we are getting here. And finally, the third value of x3, that is 0.245875 as per our calculation. And again here it says the value of x3 is 1.019. Okay, so here that means that we have made a small error here. So just a minute. Yeah, okay. Maximum 2, this is the matrix that we have entered. We are getting the values. Okay, so let me check whether I have made any mistake here or not. Just give me a minute. I'll just check what is the issue that we are having. Okay, so there is an issue in the calculation that we have made. The code does not have any particular issue. So here it is 25 minus minus 2 multiplied by 0.85. So that gives me minus 1.7. So this is correct. Again, 3 multiplied by minus 1.0275, that turns out to be minus 0. So this is correct. Minus 1.7 is correct. So I need to add this minus 1.7. Okay. And I need to add this in 25. So again, adding 25 here. So this is not 9.17. 9175. It is not 9175, but it is 20.2175. So this is 20.2175. Now, if you divide this by 20, that is 20.2175 divided by 20, that gives you the answer as 1.010875. 1.010875. So here my answer is 1.010875, and my system takes the answer as 0.0109. So it is converting this, the fourth decimal has been converted. So this is approximately equal to 1.0109, and this is exactly what my system calculates. So again, another beautiful example that humans can make mistakes, but machines cannot. So again, until and unless the code is written right, there are high chances that human would make mistake. But if the code is written wrong, obviously the machine is going to make mistake. But here, as I said, there is no problem with the code. The only thing is we had made a calculation mistake. So this is the x1, x2, x3 which are being used. Now using this particular new values at the end of the first iteration, what we get, the value is 1.025 minus 1.0275, and the third is 1.095. Now understand that we have already calculated the answer in the first method using the same data, and we know the answer is, I know the answer is 1, minus 1 and 1. So the similar answers could be seen here. Only the decimals after, only the digits after decimals are changing. So when we're talking about the optimization part, the amount of error is moving down. So at the end of this, the first iteration, what I get finally is 1.0025. My x2 turns out to be minus 0.998, and my x3 turns out to be 0.998. And again, I'm moving to the second iteration, which gives me the final value as 1, minus 1 and 1. But again, here the error would be in e raised to minus 13, minus 14. So you're not getting the final value. And finally, at the end of the eighth iteration, no, at the end of the 11th iteration, my error, which I had asked to be 0, turns out to be 0, and I get the value of 1, minus 1 and 1. Fine. So this is how your things are calculated. You have to be very, alert when you are calculating. At times, we make mistakes in calculating also. So I want you to solve all the 4 numericals that we have done. 2 numericals that we did yesterday and the 2 numericals that we have done today. You have to write it down and submit the same as well before the examination. Your examination is on 29th of March. That is Friday, 29th of March. Next Friday is your examination at 9:30. So you just go through this. The code has been provided. You have the data. You have everything. What is now required from your end is just practice, practice, and practice. We had also seen of finding of the calculation of the eigenvalues yesterday by entering the matrix and using a simple syntax for finding out the eigenvalues and the eigen matrix. I'll also share a code with you, again a very simple code which will help you in understanding that how the entire formula could be broken down into codes and you can find out your eigenvalues as well. Right? So that would also be shared with you. I would like you to go through this. And moving to the final part of the this particular MATLAB codes, that is graphical representations. So I would like you to have a look at these graphical representations also. But before we move that, I would like to know that anyone has any doubts during this particular sessions where we have discussed how a particular mathematical methods can be modeled using MATLAB coding or MATLAB scripts or MATLAB live scripts. Any doubts so far in whatever we have done? If yes, please let me know. If no, it's great. If you do not have any doubt and you have understood things, it's great. Okay, so since I don't see any hands up, so I believe that people have understood. And let me move to the next part, that is the graphical representations. So now here what we are doing is we are plotting the data against the index numbers. So here, let's say it says x is 1 colon 2 colon 10. So that means I am plotting the values from 1 to 10 with a difference of 2, which is an incremental difference of 2 because this is positive 2 and not negative 2. Okay, if this is negative 2 and if I write this as 1 minus 2 10, it is still wrong because if I want a negative a decline by 2, if I want the values to deteriorate by 2, I want the initial, it has to be having the initial value higher and the final value as lower. So if I write this as 10 minus 2 1, then it is okay. If I write this as 1 2 10, so this is how it is going to give me, right? So I have given the x value, the x here. If you want to label the x axis, you have to use the command x label. If you want to label the y axis, which is given here as value, you need to label this as y label. If you want to provide a title to the chart, you need to use the keyword that is title. Okay, then whatever you write it in the inverted commas, that would be given as the title. Now let us understand here, you are producing the value from 1 to 10 in the step of 2. So that means you'll have only the values at 1 3 you'll have the values, will only have 5 values. So what you are doing here is you are placing these particular 5 values, which is 1 3 5 7 and 9. So the value 1 is here, then at the next, that is 2, you will have the value of 3, then at 3 you will have the value of 5. Okay, again at 4 you will have the value of 7, and at 5 you'll have the value of 9. So this is how it is done. So again, a very simple code and which could be understood very easily. Now let's see that if you want a certain sort of comparisons to be made in the graph, so you want the line style to be different. So again, that could be incorporated using MATLAB code itself. So here, if you say, see here, you have given the value of x, you have given the value of y. So, and then you are saying plot x comma y. So when I say plot x comma y, for each value of x, the value of y would be plotted. But that is only and only possible if the dimensions of x and y are same. If the dimensions of x and y are different, your graphs would not be plotted on MATLAB. So here you can see that it is x is a row matrix, which is having a single row and 5 columns. Similarly, your y is having a row matrix where you have 1 row and 5 columns. So since the dimensions match, you can plot this x comma y. So now when we plot this, we can say for x value of 1, I have a y value of 2. For the x value of 3, I have the y value of 2. So at 3 also you can see the y value is 2. Then for the x value of 5, I have the y value of 3. So x value of 5, I have y value of 3. Then for the x value of 7, I have the y value of 1. So at x7, I have y is 1. See, understand, this is not 0, this is 1. Because it starts here from 1. And finally, for x, final value x is 9, I have the final value of y as 5. So at 9, I can see the value is 5. Now let's say I want to resize this particular image, and I don't want to do it with the help of a code, because there are certain modifications which I want to do it without the help of the code, because I have to modify it again and again just to use those particular graphs, whether in a report or whether let's say you are publishing a conference paper or say a journal paper. So there are, if you are using a single column format for a paper publishing, in that case you can directly use this particular graphs. But let's say if you are using this for two column sort of format, so in that case you can simply click on this particular arrow, which would give you a MATLAB figure something like this. Now based on this, just click on this particular arrow, and then you can simply double click on the particular graph, and then you can change its property. Let's say if I want to change the color, I can change the color of the graph. Fine. If I want to increase the thickness of the line, I can simply change the line width from 0.5 to 2, and I can see that this particular thing is changed. If I want to change the line style from double dash to, let's say, dash and a dot, that can be done here. If I want to change this to any particular line style, that can still be done. If I want to make it continuous, I can use a single dash. Double dash would give me a dotted line. I can also change this particular spacing between the markers. Okay, so I can also change the marker size. So multiple things could be done. I can simply add a legend here. Okay, and I can name that particular legend whatever it is. Then I can also change, I can also add the grid lines here. Okay, so here I can simply click on this, and if I say I want to add grid lines, so I can simply click on grid here. If I want to add X grids, it would look something like this. When I say X grids, that at each point of X, I can see a line passing. And when I say about the Y grid, it would look some at each Y points, I can see the grid lines passing. So I can do anything possible, even if I don't want to use codes. Fine. So you just need to explore this to understand that how this is being done. Okay. So I hope this is clear, that how you can create this with codes. And okay, now this MATLAB has a very interesting function as well. So if you want to change the X limits and the Y limits, it can also see, let's say if I'm doing this, so I'm changing my X limits and the Y limits. So it will help me in updating this as well. If I say I want to coincide this, let's say I want to zoom out this, and I want to keep this as my limit. So here you can see this code has been generated. So this is the best advantage of a live editor, that I don't need to replace this. I just need to copy this, paste it into my code. So my X limit and the Y limit has been changed. My X limit is from minus 6.9 to 14.9, whereas my Y limit has changed from minus 1.9 to 8.9. So using this, I can just simply change this. You can see my code is been changing. Just simply copy this, paste this, and you can get the desired. And then you just need to copy this figure and place it wherever you want, in whatever representations you want. You can paste this and utilize this particular figures. Fine. So any doubts in plotting this particular figure so far? Any doubts? Yes or no? Fine. Again, I wish I had a more interactive audience. But again, since I don't see any hands raised for the doubt, so I'll move ahead to the next part, that is script for plot formatting. Again, I've used a particular graph where I have used my x's from minus pi to pi, and again, if I run this particular section, okay, just a minute. Okay, so from minus pi to pi divided by 10 by pi, this is giving me the value of x. Now again, I'm not seeing the value of x here. So if I remove this semicolon from here, it would, and if I rerun this particular section, it would give me the value of x here. Now I'm also not seeing the value of y. So if I run this, I will see the value of y as well. And finally, if I plot this, I'll finally see the value of x and y, as well as I'll see the graph which is being plotted, and it looks something like this. So each value of x and y. Now, what is the difference here? Here we are also plot. See, since here you are plotting x versus y, you need to write the command x versus y. Then what you're doing is you are marking this as double dash, so that indicates that this will be a dotted line. Then you are writing this RS, which indicates that I want the color of the line to be red in color. The next I have is the line width. So the line width of the graph is 2 mm. So here, if you see the previous graphs, the line width was comparatively thinner. So here I have increased the line width to 2 mm. Then the marker edge is also what we are coming into. So I am using a marker of the edge color. So the edges you can see are having this particular markers place. The marker color is also what I have decided. You can see this particular G, which represents the green color of the marker. And finally, the marker size. Sorry. Finally, the marker size, which is I have given it as 10. So again, depending on your paper sizing, you can use this. So I've just added this particular practical into your session is because most of us are going to use the MATLAB for your particular coding, getting your results and publishing papers out of this. So that is what we can be using this for. So this particular part of the uh, session would be helpful in you using this particular graphs and representing it either in your report manuals or also in your uh, publications, if at all you are going for that. Fine. So I hope this is clear. We'll move to the next part where we have to plot. Just give me a minute. Yeah, we'll plot the curve for the mathematical function that is y, and for each where y is the square of x. Now, see, we all understand that if we are using this, we'll have a sort of an exponential graph. Now, please focus on this particular y here. It says x square y nahi hai, yahan pe x dot y square hai. Now, why are we using this x dot y square? This dot indicates that for each value of x, we are squaring it and placing the value. So, for value of x is 0, we are getting x square as 0. For value of x as 1, we are taking this as 1 square. So, you are not taking the entire value of x and then squaring it. When you place a dot after the particular variable. So that means for each variable of x, you are using this particular exponential, that is exponent of 2, which is nothing but square of x, and then returning the same value to y. So for each particular value of x, you are squaring it and it is being placed to y. So this is how it can be plotted. So this decimal is very much required for giving you the values for each and every graph. Next, moving and giving you an output of a sine wave. So here I need to give the range of x. So what I've given is 0 to pi by 50. So my entire one cycle can be divided into 50 parts, and then it is incremented by that part till it is 2 pi. Okay. So for one particular cycle, this has been done. Next, this is my x, and for y my values are sine of x. So for each value of this particular x, I am multiplying it, or say I am providing those particular value of x to the sine function, and that particular answer is being returned to my y variable. And once that is done, I am plotting this. Now, once I'm plotting this, I am asking the MATLAB to plot x versus y, but I also want to make sure that my markers are star and it is also dotted. So I can see the space between the two markers, and my markers looks like a star. Then similarly, the X label, Y label, and the plot of the title that can be used, that we have already seen. Fine. Now, let's say you have a 3D graph and you want to plot a graph into a 3D section. So this is how you can do this. So for t is equal to -4 to 0.1 to 4. So this is the incremental part which is given to you. Now for x, you are plotting it for the square of that particular value. For y, you are taking it as 4 into that particular values of t, for each values of t. And finally, you are plotting for x, y, and t. So once you do this, your t is nothing but your z-axis, and you can plot this as x, y, and z. That is your three-dimensional plot. So you can use this as well. Okay. Moving next to sinusoidal curve. Let's say I want to plot this sinusoidal curves. So I need a particular value of voltage, since I'm plotting a voltage. So I've taken my voltage value as 230 into square root of 2. You can use any particular value. That's all up to you. After that, I've used a particular theta, which is from 0 to 4 pi. 4 pi means nothing but I'm doing this for two particular cycles. Okay. And again, that is being incremented at 0.001. So my theta increases from 0 to 0.001, and it will keep on increasing till it reaches my 4 pi. Then I have three voltage signals that are to be generated. That is Vm into sine theta. Then I have Vm into sine theta minus 2 pi by 3. So which would be leading this particular waveform. And the next is that would be lagging this particular waveform. And the next would be Vm sine theta plus pi by 3 plus 2 pi by 3. So that would be leading this particular waveform. Now, I have given these values into VR, Vy, and Vb. Now I have also mentioned VR is nothing but voltage of my red phase, Vy is nothing but voltage of my yellow phase, and Vb is nothing but voltage of my blue phase. So I have simply represented that using these particular variables, that I want my VR into red color, Vy into yellow, and Vb into blue color. Also, you can see that I have used different sort of markers for this. Here is a plus, other is a star, other is a this. Now I cannot see this when I am having this particular spaces. So what I'm doing is I'll zoom into a particular section so that you have an idea. Let's zoom into this section. So if I further zoom this, you can see that what I talked about, my markers are actually seen here. The only difference is that you can see this particular markers only when you zoom into this particular thing. Again, for the yellow one also, let us zoom into the yellow section. So you can see here also where we had asked for the star markers, you can see the star markers here. Okay. So this is how you can. So as I said that MATLAB is a very beautiful tool when you want to plot particular graphs. It gives you better graphs compared to plotting the same data into Excel. Also, MATLAB has a capability of uh, dealing with a higher amount of data in a smaller size compared to your Excel, and also has the you can add more creativity to this in MATLAB. When I talk about creativity, is that is the requirement of the particular graph to be placed in whichever format is required. You can also set the DPI of the format. Let's say if this is a particular graph, I can turn this to figure, and then by using figure, then going to the, let's say, export setup. Coming to the rendering part, I can also change the DPI to say 500, 600. Also, I can mention it to, let's say, 1200 DPI as well. So, and then apply it to the figure. So based on the requirement, you can change the resolution of the figure that is generated as well. Now, such features are not available in Excel or any other particular tool. So that is the reason that MATLAB is again used for such sort of comparisons as well. Finally, coming to having a single figure with subplots as well. So now again, let me remove this particular semicolon so you can have an idea about A, B, C, and D which are being generated. And then let us run through the code again. So here, okay. So now A, B, and C are A, B, C, and D are being mentioned here. So these are the values. Now, when I use the subplot, so subplot 2 comma 2, so that means I am dividing the figure into 4 figures, which has 2 rows and 2 columns. And out of that, when I place the first figure, so it is between plot A, B, A versus the title is A versus B, which is being placed here in the first position. Now, look at the second part of the code, which says subplot 2 comma 2 comma 2. So you have again 2 comma 2 as 2 rows, 2 columns, and in that you are placing this at 2. So again, you'll first fill all the rows, then all the columns, then we'll go to the next row. So similarly, as you add the values in the matrix, similarly you can add figures here as well. So subplotting 2 comma 2, so that means in the 4 figures you are placing it this at place number 2. So that would be first row, second column, and there it is A versus C. Similarly, subplotting at position number 3, so that would be second row, first column, where you would see A versus D. So this is the A versus D graph. And finally, the last is at place number 4, that is B versus D. You can have this as B versus D. So such type of subplotting in the similar graph could also be done just by writing such simple codes. Okay, so again, this part of the the code would also be shared with you, so you can have a, idea to how to run such particular codes as well. So such things could be asked in your examination as well. So any doubts in these particular coding so far? Any doubts here? Any doubts in any topic that we have covered during this last almost 2 hours? We are running this lecture for 1 hour 15 minutes. Any doubts so far? Yes, no?
No, sir.
Okay, great. So if we do not have any doubt, I think we can end the session here. So thank you so much for joining, and we'll now directly meet at the examination. The location and the time would be shared to you. The date I have already provided, that is 29th of March. In between, try it out, and what you are asked to do is you'll have to write the numericals and draw a flowchart of that. Also, you'll have to plot this particular things and give it to you. Submit your files before the examination. Okay, so I'll also give you a dedicated date for providing your manuals as well. Let us fix the date itself. Okay, your examination is on 29th. I would want you to submit your files on 21st, which is a Thursday. Because this week would be working. After this week, there is what do you say, certain students might not be coming because there have been certain online session schedules for them. So I'll not disturb you during this online sessions, but I want you to submit your files before 21st. I'll share you an official mail for that as well, but I want you to submit this before 21st. Fine. So any doubts so far? This is the final time I'm asking. Any doubts? Please ask. Okay,
Sir,
so
can
no
you
doubt.
repeat what we have to do in the manual?
In the manual, you have to solve the numericals for your tutorial 3 and 4. You have to write it manually. Okay. Solve those particular numericals, and then you have to submit those particular files. Fine. You'll also have to draw the flow diagram, say flow chart of those particular, so that you have an understanding that how this particular thing works. The code is already provided. The result of the codes have already been provided in the manual. There are 2 more experiments that would be shared with you. 5 experiment has been shared with you. We'll be sharing 2 more experiments with you, so that a total of 7 experiments needs to be done. And be prepared for your practical exams. There might be very small codes also which would be asked with you, like ask the user to write their name. I ask the user to, let's say, write your mobile number or any particular details and print it on the screen that your good name is this, your personal information contains this and all those things. So such sort of questions could also be asked with this particular uh, coding data which we have just gone through. Fine. So thank you so much and have a great day. We'll catch up in the submission part. Okay. And in between also, if you have any doubts, please feel free to meet me. I sit at electrical engineering department, room number 108. Fine. So thank you so much and enjoy your Sunday. Thank you. You're free to leave the
Thank you,
meeting.
sir.
Yeah, thank you. Bye.